First of all, what we have is the sunspot cycle celestial modulation, which I described to you, looking at this cosmic ray flux and the sun changing over time. That has a big impact upon cloud formation on the planet as a whole. This in turn has an impact on something called planetary waves. Now, this is a fancy term. These are large-scale movements of atmosphere all around the planet, and the best example I can think of is the jet stream. Is a major thing which migrates, and at least on our weather channel here, I look at it every night and they're always showing, here's a jet stream, and this is why it's crappy here today, or this is why it's going to be nice today. And so this has a big impact upon this, what's happening with the Aleutian Low and the North Pacific High. So this has the correlation right here. Impacts the center of formation of the North Pacific High and the Aleutian Low, which are moving by up to 700 kilometers across the sunspot cycle. So think about what's happening here as we move up to Gleisberg cycles, when you start to enhance the impact by 3 to 4. So this is an enormous impact upon upwelling in this region. And this enhanced upwelling, then, is what we're seeing with our nutrients and our diatom production. So that's the climatic link between the proxy records that we see in Effingham Inlet and what's happening in the bigger global picture. The next thing I wanted to show you is that I mentioned with these Gleisberg cycles, they record intervals in here between high sun intervals when you have a peak solar production and intervals when it's lesser. And so here's, again, I showed you this diagram. Here's a high sun activity 4,400 years ago. Here's a low sun. Here's a higher sun interval again. I want to show you exactly what happened right at this point, and we'll look at it actually visually. And this is a nice thing about this sort of a time series analysis. You can actually lay the core down beside it and say, oh, what was going on here? Why does this cycle show up? And here's what happens. This is a 62-year climate record right here from 4,400 years ago, year by year by year. And the question would be, so what? What's the big deal about this? The big deal about this is everybody always talks about, when they talk about climate change and so on, well, you know, climate's going to change suddenly, more suddenly than ever changed before, and so on. Well, you know what? Climate can change very suddenly, and it can change very profoundly. And here's an example of that right here. Here are these thick layers right here, year by year by year, and everybody in the room could recognize then these are thicker, lighter layers. These are enhanced upwelling. Okay? This is the high sun interval right up here, when that sort of a light area right here. But look at this record, right at this point right here. Suddenly we moved from a high sun part of a Gleisberg cycle to a low sun one, and almost over the point of one season we change to a different climate regime here. We see these darker, thinner layers. The diatom production is greatly reduced now, and now it's a lot of these darker, muddy layers from enhanced rain. The Aleutian Low is starting to dominate at this point, as opposed to the upwelling that was going on with the North Pacific High. And this occurred like that. Okay, so this is massive climate regime shift going on almost instantaneously. So it's ludicrous, the idea that climate can change on all scales. It can change slowly, it can change dramatically, such as we change around here. It can be colder or wetter. The records that we see here show how dramatically fast that change can be. Now just move to the north for just a couple of slides here to show what's happening up in the more continental regime. Okay, this is Belize Inlet, and this is a line right here. All these colors right here basically are showing changes in temperature, oxygen, and salinity that we measure with probes that we stick in to give us water property data. And so this is this long red line. Then this over here is another little inlet, which is blue, which basically you can see changes in temperature, oxygen, and so on. The main point I want to show here is that on top of in this inlet up here, the water doesn't have a very high salinity. This is a low salinity wedge around here. It's very fresh. The same thing up here, very fresh water, and it's more saline down below. And what's happening here is that it's difficult for water to become exchanged through this place called the Natwatko Rapids. The waters here is probably one of the highest tidal flows in the world at 8 meters per second. You'd be swept away if you were put in this water right here. This just shows the standing wave as the tide is turning in this particular place right here. So exchange is very, very difficult. And as a result, this place is not greatly influenced by the open ocean like we saw down in the south at Effingham Inlet. It's controlled largely by estuarine flow, the amount of rainfall that's coming into this area from streams or from other sources. So this is what we're seeing, although you do get a little whiff of some temperature change coming into the place. But we see the same pattern. up here. The high sun activity, the low sun, high sun, low sun, all responding not so much to upwelling this time, but it's responding to changes in rainfall. As the Aleutian low, which dumps lots of water around here, moves in, dumps water in this place, and then the North Pacific high so this is when you have North Pacific high, this is Aleutian low. So this is low rainfall, high rainfall, low rainfall, high rainfall. So it's not upwelling, but it's the same sort of phenomena. So it's a completely different oceanographic regime, but exactly the same sort of pattern going on. And what I think this is analogous to is like the little ice age in northern Europe. So here's something called the Maunder minimum. This is a time when sunspot cycles largely disappeared from that part of Europe, or basically from the world. Then they start to reappear again. So here's a sunspot cycle getting longer and longer and longer, a Gleisberg cycle it's piggybacked on top of that, and another one, and here we are up to present time. So we've gone from this sort of a cold condition, low sun conditions, up to much warmer conditions as we have at the present time. So it's the same sort of cycles and trends that are going on. Okay, here's Bruegel's Hunters in the Snow. So a picture from northern Europe. And so this is sorts of conditions that you do not see there at the present time, as existed during the Maunder minimum when there was hardly any sunspot activity and lots of cosmic rays getting in. Here's the more interesting bit right here, is that we can actually then look at these different species that live around here, and you can see that in a very short freeze core that we took from Belize Inlet, that there was a radical change in this place. So there was some of these species were very abundant deeper in the core, then we changed to a totally different set. And using this thing called the transfer function, we can ascribe oxygen values and temperatures to these distribution of these fossils. And what we saw, the interesting thing is that at a point right here, and I think I'll move to another slide to show that, is that here is the transfer function. This is dated from about 1000 AD up to the present time in here. Up until about 1500 AD, oxygen levels in Belize Inlet were very low. Then almost instantly, they moved up to much, much higher levels. The same thing with temperature. Temperature was higher, then almost instantly around 1500 we moved to a lower temperature, which stayed all through the 1800s until the latter part of the 1800s, when it gradually, the temperature started to drop off and oxygen started to drop off as well, which matches up beautifully with the Little Ice Age. So I think what we're seeing here is another one of these Gleisberg cycle shifts that we're looking at. And here's just a little model to show how this happened, is that Belize Inlet, during the time when oxygen levels were low, basically it rained a lot in this area. So enhanced rainfall, which resulted in a very thick wedge of fresh water going across that very narrow little Waco Rapids out here. Water couldn't get in from the open ocean at all. And it resulted in this water in here becoming very stagnant. Then, as we moved on later, Belize Inlet, as we moved, the North Pacific High began to dominate in that area. It resulted in lower salinity water leaving, but it's a thinner wedge, and some water could actually get in, and oxygen levels start to go up again. And so it can happen very, very quickly. It doesn't take much. If you add a lot of water into this very narrow little inlet up there, it can result in a serious restriction of the amount of exchange going on and almost instantaneous development of anoxia. So this is our Little Ice Age record that we see in this region as well, which is controlled by, again, these movements in the North Pacific High and Aleutian Low. It's not upwelling. We're looking at changes in actual rainfall at this stage. So finally then, the conclusion that we've drawn from this research, carried out over several years here, that basically we see very conclusive, I'd think, evidence of natural cyclic phenomena, which we think is driven by these celestial variation, which has an impact of the solar forcing basically being modulated by cosmic ray flux, which seems to be a prime driver of not only climate in the Northeast Pacific, but also has a profound influence upon biological processes as well.